Hey there, it's Mrs. Thompson. We're going to go over endothermic and exothermic. We'll talk about processes and we will also talk about reactions. Before we get started, we're going to talk about energy transfer, but we need to define a couple things. We need to define the system, the surroundings, and the universe. Now, the system is a specific part of the universe that you're currently interested in. Let's say you want to dissolve a salt in water to see how that changes the temperature. The salt in the water would be your system. Everything else would be the surroundings. So it would be the beaker that you hold it in, it would be the air around that beaker, the classroom around that, and then the town around that. It just keeps expanding until you've encompassed the rest of the universe. The universe itself is both the system and the surroundings. So careful, the universe is everything. We'll be looking at how energy is being transferred, either from system to surroundings or surroundings to system, and we'll look at how that changes in heat energy. So we have delta H. Delta is that little triangle symbol. It just means change. So we're looking at how there's a change in heat energy. If we're going from the system to the surroundings, so this green arrow or aqua colored arrow, we have an exothermic reaction going from the system. The energy is coming out of the system and it's going to the surroundings. Our change in heat energy is negative because the system is losing energy. It's exothermic. Delta H would be negative because it's losing that energy. The opposite is true when the system absorbs energy from the surroundings. We call that endothermic. It would have a positive change in energy. So our delta H would be a positive value. This picture just shows you when we're looking at endothermic, the energy is being absorbed from the surroundings. And so what that does to the temperature of the surroundings is it actually makes it cooler. So the surroundings will get cooler in an endothermic reaction. You can see on the left there's a thermometer. The temperature will fall as that gets cooler. For an exothermic reaction, if you're sitting outside of the surroundings, right, and heat is coming out of the system, then you're going to feel that heat that's coming out of the system, and it's going to make those surroundings feel warmer or make the temperature increase. Same thing. Okay, so then I have a couple of charts for you to help you kind of organize your thoughts. For endothermic, heat is absorbed. We can say it is entering the system. Enter endothermic. For exothermic, we're looking at heat being released. It is exiting the system, so exothermic. So the prefix ex meaning out, right? Exothermic, heat is going out, it's exiting. For delta H, we want to have positive values for endothermic because it's increasing in heat energy. This would mean that it's greater than 0. So sometimes it's written as delta H is greater than 0 instead of saying positive. Other way would be a negative delta H for exothermic because it's releasing that energy. And so we could also say that it's less than 0. For the energy of the surroundings, I have a picture here, a cold pack. A cold pack absorbs energy in order for the salt that's inside to dissolve. And it absorbs energy from you, the surroundings, when you touch it. And so you're actually going to feel colder when you touch a cold pack. So it decreases the energy of the surroundings. We feel colder. For exothermic, the opposite's true. Like a hot pack, you break that water inside the hot pack, it dissolves the salts, that makes it exothermic. It releases heat to you, the surroundings, and it feels warm. A few questions for you as we go through this ed puzzle. First one, check for understanding number 1. A student holds a hot pack in order to observe the temperature change that occurs when a hot pack is activated. Identify the system, surroundings in this experiment. Question number 2. A hot pack utilizes the dissolving of urea. The dissolving of urea is an exothermic process because what? Check for understanding number 3. Which statement below is not correct? Okay. I said we would discuss processes and reaction. First, we'll discuss processes. We're going to focus on phase changes, although what we did in the past with the dissolving of salt was also a process. Okay. So for endo and exo phase changes, this is a process. So we're looking at something that isn't changing the state of matter. It's not a chemical reaction. It's staying the same state. We're just changing the spacing between the particles. Okay. So let's talk about all these. You will need to know all of them: melting, vaporization, freezing, condensation. Those are the ones that you normally will remember. Sublimation and deposition are you need some reminders of usually. Remember that sublimation is going directly from a solid to a gas. An example of this would be dry ice subliming into that fog that you see in dry ice in cool movies. For deposition, you have gas turning directly into solid. That is an example of that would be like frost forming on your windows. The water vapor from the air instantly freezes as it touches your cold window, and you see the little crystals form on the window. Okay, so that's enough about phase changes. Let's talk about whether it's endothermic or exothermic. So going from a solid to a liquid, you have to think, is it going to require me to put energy in or release energy? So in order to melt ice, you have to heat it up. So melting would involve the addition of heat energy. So that would be endothermic. Liquid to gas, vaporization, you have to add heat to get water to boil and turn into steam, right? That's also endothermic. So it looks like going from left to right, we have some endothermic phase changes. And that is also true of sublimation. So in this direction, endothermic. In the opposite direction, we have gas to liquid, liquid to solid. That's going to be exothermic, but let's talk about why. And when I think about these, it's kind of tougher to think about adding heat or removing heat. So I like to think about how fast the particles are moving. Going from a gas to a liquid, gas particles have lots of energy and they're moving a lot. In order to turn into liquid, they have to come closer together and move just a little bit less. And so as they decrease in the amount of energy that they have to give up that energy to the surroundings. So going from gas to liquid, releasing that energy into the surroundings, and you have that exothermic phase change. I know it's kind of weird to think about, like if I put water in the freezer, that it's an exothermic change, because usually we think about heat being given off, right? And heat is being given off to go from a liquid to a solid. It's just we don't notice that, right? Because we have our refrigerators that we put that ice in, and the refrigerator takes the heat out and puts it into the back of the fridge, and those coils get warm. But it is something that is exothermic. Those liquid particles have to slow down in order to turn into a solid. They release that energy in doing so. All right, so you have some more check for understanding questions. You're going to write down which phase changes are exothermic. Here's another one. Which of the following is an exothermic process? Here's number 6. What happens to the temperature of your hands, the surroundings, when snow melts in your hands? Number 7, what happens to the temperature of the surroundings when water freezes? Okay, So now that we've talked about those endo-exo processes, let's talk about endo and exo reactions. So remember from our dissolving periodic dissolving and temperature changes, we looked at bond breaking and bond forming. So bond breaking takes energy. You need energy to go in there and break up those bonds. And when they form new bonds, they actually release some energy. And that's the reason why they do it, to get rid of energy. And so in a chemical reaction, you have both bond breaking and bond making. You have the bonds being broken in the reactants, then they rearrange themselves and they form new products by making new bonds. And so when they do that, you have endothermic process or endothermic part of it being the reactants breaking up, and the exothermic part of it being the new bonds being formed. We don't think of reactions in that way. We don't think about both things going on so much. We talk about them as, are they endothermic or exothermic overall? And so whichever one is greater, that's what's the one it's going to be overall. So if it takes more energy to break the bonds than it does release energy, then it is endothermic. More energy is going in than coming out. If in the other case, if it's releasing more energy when it's forming new bonds than it used when breaking the bonds in the reactants, then it's exothermic. More energy is exiting. Okay, here's some energy diagrams. They're a little simplified. We'll talk about some more of these later. But this is endothermic reaction and an exothermic reaction. There are two different ones, so think about it as a line right here. This is for endo, that's for exo. In this, you can see what's going on with the energy. So on the y-axis, you have stored chemical energy. The reactants are always on the left, the products are on the right. This is the direction of the reaction. So reactants to products. In the endothermic diagram, we have reactants with low energy and products with higher energy. And so in order to get that to happen, you have to add some energy. So energy is absorbed from the surroundings. So this would be a positive delta H. Energy is increasing from reactants to products. We could also say this as products have more energy than the reactants. Okay, let's talk about the exothermic version. It's just the opposite. The reactants start out high, and then the products go low in energy. And so in order for reactants to turn into the low energy products, they have to release energy to the surroundings. Okay. In a thermochemical equation is what we'll be looking at. Thermo meaning heat, chemical equation, just like balanced equations we talked about a long time ago. In a thermochemical equation, energy is added to the equation, and it could be written as heat, could be written as energy or even light, or it could have some sort of energy unit. It could say something like 25 calories or 250 kilojoules or 115 joules. Could be any one of those with an energy unit, which is why we spend some time looking at energy units. Notice in this reaction, we have photosynthesis. We have carbon dioxide and water coming together. It needs sunlight in order to happen, right? Heat here, and it makes glucose and oxygen. So the heat's written within the equation. Okay, so we're just going to put this all together in a table. For an endothermic reaction, it takes more energy to break the bonds than it releases. In an exothermic reaction, the bond formation releases more energy than it takes to break bonds. In terms of which one has more energy, the products have more energy in an endothermic reaction. In an exothermic reaction, the reactants have more energy. For the side of the equation it's written on is, if you're looking at a thermochemical equation, energy is written on the left for an endothermic. Energy is written on the right for an exothermic reaction. When it's written in that reaction, heat is a reactant. in an endothermic reaction. In an exothermic reaction, heat is on the product side. Heat is being made. Endothermic, heat is being used. Okay, so let's see what that would look like. For an endothermic, we have heat on the left of the arrow. Remember, the arrow splits up the reactants and the products. We could say that heat is going into the arrow endothermic. For exothermic, heat is coming out, so it's exiting the arrow for exothermic. This one has it in terms of a number instead of the word heat, but it could also say heat here instead. Could say heat, light, could be joules, could say energy. So I have a few more questions for you. Here's number 8. Which one of these is exothermic? Next, which of the following is an endothermic reaction? So pay close attention to where the energy is at, reactant side or product side. Number 10, which of the following reactions decreases the temperature of the surroundings? So first you need to think about whether it's endothermic or exothermic and which one decreases the temperature of the surroundings. Number 11, which one requires more energy to break a bond than energy is released during bond formation? Exo or endo? Number 12, what happens to the temperature of the surroundings when a bomb explodes? So think about whether it's endo or exo, and then what's going to happen to the temperature of surroundings because it's endo or exo. For 13, which of the following does not represent energy in a chemical reaction? So which one should not be in one of those thermal-chemical equations? Number 14, what type of reaction is this? Is it endothermic or is it exothermic? Okay. With the Ed puzzle, you should be able to see whether you got your questions right or wrong. If you have any questions about any of the answers, please talk to me during class or during a Zoom session next time we meet.